Hi, so let's go to the second question of Lab 3. This time I will spend more time to explain the design of recursive method. So we define a recursive method that read lines of text from one file and print it in another file, but it is in a reverse order. So thinking about the approach that we can do if we want to do looping, we can actually do it pretty easily. Just store it in some way like an array or list. Then after this, I will read from the behind, loop from I equals to n minus 1 until n equals to 0, for example, to print it into the another text file. But if you want to do in a recursive way, you need to design your recursive method first, definitely. So the first thing you need to do is to set the stopping condition. Stopping condition is the condition where your function will return something, or it will stop doing anything. So this is a stopping condition. If it achieves a stopping condition, then stop the method. Else, you will continue doing a recursion. Now, have a look at the code base. This main method will have a buffer reader to read from A, and we'll have a print writer to write to B. Then I'll call the recursive method read write file with some dummy text. This hey is a dummy text, which indicates that we don't want to print this line because this line is just basically nothing. This is just a dummy one. I don't print it to the text file, but it's required so that the program will not print out the first input that we put to the method. If I just simply put the empty string, it might happen that the program will print an extra line break because it doesn't recognize this as a empty string, but it recognizes as something inside the text file that needs to be printed. Well, spend some time to think about the logic, then put inside the buffer reader, then print writer. So don't forget to close both buffer reader and print writer so that your modification can be saved in the text file. Now have a look at the recursive method. So in this recursive method, I will have a text which is the text to be printed, a buffer reader and a print writer. So TMP will read the next line if possible, and definitely in this case my stopping condition is when the next line is equal to null. It means when I am not able to retrieve any text anymore, I should print the final line, the txt, and return the statement so I can continue, so I can return back to the previous function call. So if I haven't achieved the stopping condition yet, I will call again the function, the recursive function. So passing in the next line and br as well as pw. So here, this line will only be called after the function has returned something. So later I will show you the scenario by visualizing in the text file. Well, if the text is not equals to hey, I need to print it to the text file. So this is exactly what I mentioned just now. Hey is just a dummy text to stop the program from printing an extra line. So it might not make sense to you at first, but try to think about the recursive method. As I mentioned, recursion is it requires some practice. So I call the read write file as the fu. I call it as func, so we don't have to write lengthy text. So let's say this is the first function call, which is hey, br and pw, right? Then after that, I will be able to read the first line, line 1, br, pw, and I will continue reading more text if I can using the br.readLine. So I will get line 3 until n times, until I've reached somewhere where the TMP equals to now. So let's say this function call of line 4 is the final line that our function have. Then brpw. Here, I will use the condition where, I get it, TMP equals to now. So remember our stopping condition is to print something then return the statement. So here I will print the line 4 to the b.txt already. So this is the first print I have. So now you can see, oh, by doing the recursion, I only print the text when I reach this stopping condition, or when the function that reached stopping condition has returned something. So remember I could put some return here. So this return will actually return the recursive function to the previous one. So let's say this is b.txt here. Then it will return this to the line 3. So here it will invoke the print line 3 to the b.txt. So after this, it also, after it has done this, okay, after it has done this, yeah, it has ran its end, right? It has reached its end. So it will also return a statement to line 2. So this is the line 2. Then after that, go back to line 1. Then after that, go back to hey. But hey, I will not print anything because I already said hey is dummy. So this is the logic I have. Calling function inside function. Actually function is method, yeah, same thing. So if it's equals to null, I will print the text and return a statement. If I have reached the end of statement, I will also return a statement. So this means I have done everything including here, then I will return a statement back to the read-write file, to the previous function call. Then go back until I reach hey. Then everything will be printed as I expected it to print. Well, now you can see actually recursion is not a magic. Yeah, recursion is something like a stack. So uh, have an analogy that yeah, for example, these chips, yeah, this represents a stack. So every time you call the function, you will put the function inside the chip, then put again recursion until the end. So after it has reached the end, you want to return back the chips to it, right? So the first one will go out of the stack, then second one, no, the last one first, then the second last one, third last one until the first function. So this I hope that it can help you to understand more on recursion. Yeah, I spend more time to explain about the design instead of the solution. Because recursion, if you use it properly, you can reduce the code size to really small. But to design it is initially it might be difficult for you, especially to think of the logic, which is a little bit different from looping. So looping you do from left to right, but recursion you do left to right, then right to left. Yeah, something like that. Um, but still, whenever it's possible to use iteration, to use looping to solve a problem, yeah, try to use looping, unless the question asks you to use recursion, or recursion really give you a very small code size. Well, that's it. Yeah, I hope it can help you. See ya.